Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. If you have ever wished that you could use the same tools for versioning and distributing your data that you use for your software, then you owe it to yourself to check out what the fine folks at Quilt Data have built. Quilt is an open source platform for building a sane workflow around your data that works for your whole team, including version history, metadata management, and flexible hosting. Stop by their booth at JupyterCon in New York City on August 22nd through the 24th to say hi and tell them that the Data Engineering Podcast sent you. After that, keep an eye on the AWS Marketplace for a prepackaged version of Quilt for Teams to deploy into your own environment and stop fighting with your data. And Python has quickly become one of the most widely used languages by both data engineers and data scientists, letting everyone on your team understand each other more easily. However, it can be tough learning it when you're just starting out. Luckily, there's an easy way to get involved. Written by MIT lecturer Anna Bell and published by Manning Publications, Get Programming, Learn to Code with Python is the perfect way to get started working with the language. Anna's experience as a teacher of Python really shines through as you get hands-on with the language without being drowned in confusing jargon or theory. Filled with practical examples and step-by-step lessons to take on, Get Programming is perfect for people who just want to get stuck in with Python. Get your copy of the book with a special 40% discount for Data Engineering Podcast listeners by going to dataengineeringpodcast.com/get-programming and use the discount code PODINIT40. And go to the dataengineeringpodcast.com website to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Manish Jain about DGraph, a low-latency, high-throughput, native and distributed graph database. So, Manish, could you start by introducing yourself?
Hi, Tobias. I'm Manish. Before I started DGraph, I used to work at Google. I was there for 6.5 years working in web search and knowledge graph infrastructure group. In fact, that's where I started my journey with graph systems and started DGraph in 2015. And now we are here.
And do you remember how you first got involved in the area of data management?
Yeah, I think it was in 2010. We had just wrapped up a big project at Google, real-time indexing system, and launched that. And after that, I started looking into seeing what I should do next. Google acquired MetaWeb, a startup in San Francisco, which brought Knowledge Graph to Google. And I started working with them to see how we could use Knowledge Graph in web search. And as part of that, I started dabbling my feet with graph systems in general. And that's what started the whole.
Can you start by describing a bit about what DGraph is and what your motivation was when you first started building it?
Yeah, so DGraph is a distributed graph database which is meant to scale out. It's meant to provide all the properties in database that you would expect from modern database systems. We consider it to be sort of like a new graph. And the reason I started building DGraph was I had already built a similar system at Google. It was not a database, but more of a graph serving system. And it was meant to be low latency, meant to be high throughput because it was going to be put behind web search. So a good chunk of web search traffic was going to hit the system. And what I learned from there, when I started comparing that after I left Google, this 2 years after I left Google, I started comparing that to what's outside in the graph world. And I realized the best graph databases out there were only running on a single server, didn't perform very well, didn't scale well. And then I thought it's probably something that should be addressed. There's clear need in the market, but the existing solutions were just not good enough.
And the entire concept around graph databases and graph theory and the associated algorithms have been part of computing for several decades now, but graph databases as a storage engine have been fairly nascent until recent years, which has seen a bit of an explosion in that as a particular mechanism for people to incorporate into their data layer. So I'm curious what has changed in the recent years that allows for that proliferation of graph-oriented storage systems and the interest of people using it within their systems.
Yeah, I think so. What has changed is that modern data sets tend to be increasingly sparse and highly interconnected. The connections between data sets are exploding. And to be able to make sense of these data sets, you need to be able to do arbitrary depth joins and connection traversals, edge traversals. That's something that traditional relational databases are not very good at handling and being performant at. So we are seeing, obviously SQL databases being used in companies. Then we see that they use some level of NoSQL, but then there's a clear need where they have certain use cases which can only be solved or can be solved a lot easier with a graph database and or a graph system, and that's when they go and reach out in the market to see what's out there. So almost all the medium to big companies are using some sort of graph system internally.
And because of the current interest in graph systems, there are a fairly large number of systems that are targeting that use case in various capacities. So I'm curious how you view DGraph fitting in that overall landscape and how it compares to the offerings that are available in that space.
Yeah, so I think some of the ones that I've seen have been sort of around analytics use cases, and we have systems which can compute page rank completely out of memory, etc. So I think with DGraph, we instead of like focusing upon analytics, we actually wanted it to be a database that people can build their applications upon. And so we went straight after OLTP use case, the transactional, real-time transactional use cases. And there are a few, obviously, like the elephant in the room or in the industry would be Neo4j, the most popular graph database out there, but it just has not been able to capture the market like, let's say, Postgres or MySQL have done for SQL landscape because of various issues like I would say performance and data corruption, etc. If you go Stack Overflow, you'll see some of these things. So also I felt like we don't need to limit ourselves to these kind of design choices when clearly the world has gone from, like, Google released Bigtable back in 2006 or 7, the paper upon that, and then in 20, I think 11 or 12, there was a release of Spanner paper. And so there's a race to build the next geographically distributed SQL database, but we are stuck with a single server graph database, which doesn't really perform very well. So, so clearly we can do better. And the way we have designed DGraph, we consider it to be the most advanced graph database in the market. And the idea is that we will make those design decisions, which are hard, which means we want to be able to scale it horizontally. It has to be consistently replicated. It has to be transactional, all those things which make for a good database of today.
And one of the points of confusion that comes up occasionally when people are first getting introduced to graph databases and graph storage is the potential use cases for it. So, can you discuss some of the common uses of dgraph and other graph databases that you are aware of, and some of the use cases that are often overlooked but would be a good workload for a graph system?
Yeah, so I think some of the use cases that people instantly think about graph databases, I would say, is recommendations. When you have a rich data set and you want to be able to recommend, for example, what your users should be purchasing if you are building an e-commerce website. That's probably one of the most common use cases of graph database. The next most common, I would say, is fraud detection, real-time fraud detection. In fact, we have seen a bunch of fintech and even non-fintech and highly technical companies kind of use DGraph for fraud detection. There's others like, in ad tech, you can place ads based upon users' activities and interests, and in social graph, we have seen Customer 360, where they unify vertical silos of data into one big connected graph so that they can query across these different independent data sets and be able to surface interesting information about how their customers have been with. One of the interesting things about graph, actually, to this point, is that they tend to, like, graph databases do not necessarily have these boundaries of tables, right? So you actually have the entire data set into one database, and you can query from any data point to any other data point without necessarily losing performance. And that's one of the interesting things that we have seen with Customer 360, for example. Now, obviously, there's artificial intelligence use case where you can interpret user queries and understand them better with knowledge graph, and that's in fact what I had started with back in 2010. I would say some of the overlooked use cases is the most common one would be to just build a social website, with a post, comments on the post, likes on comments, comments on comments, likes on those. This is a repeated pattern. You can see it in Facebook. You can see it in Quora, which is a question answering website. You can see it in Stack Overflow. It's a similar sort of workload, and I think you can cut down on a lot of code by using a graph database to serve this content, because you can recursively retrieve posts and the comments connected to those posts, and then likes on those comments, and so on and so forth, with a graph database easily, and cut down your code base in probably half. So that's one of the things that I would like to see, but I don't. I think it's often overlooked.
And when I've been looking at different graph systems, there are variations in the way that the data is represented, whether the nodes have attributes directly embedded in them or if they're represented as a document structure, and then whether the vertices connecting the nodes can have their own attributes and things like that. So I'm wondering where DGraph falls along that continuum in terms of how the data is modeled and stored.
So DRAM actually has a very interesting approach to this, and note that we were going for arbitrary def joins, and at the same time we want a distributed system. So I don't know of any other system which is trying to do arbitrary def joins while being distributed. So we actually had an pretty interesting design challenge there. The thing is, you can divide up the data, and this is actually nodes and edges, right? So you can divide the data in either nodes or edges. Most designs that I've seen would divide up the data in nodes because they spread out evenly across different machines, different servers. The problem with that is if you need to do joins, each join would require you to do a broadcast to all the servers in the cluster, and that significantly affects your 95th percentile query latency. So what we do instead is we divide the data by edges instead of nodes, and so we are then able to do a join with a single network call to another server. And if you have, let's say, n depth join, then you can just do n network calls, and your query will be completely executed. And this is a it's a lot more. It gives you lot lower latency and lot more sort of persistent latency, even if you increase the number of machines in the cluster. So that was deliberate design decision that we made upfront, and it's obviously a lot more complicated to build, but it actually gives us, basically reduces the number of network calls in the system and gives us a reliable latency number, which is important for real-time transactional workloads.
And for people who are moving from a relational system who might be familiar with things like data normalization and the various normal forms when they're moving to a graph system, is any of that knowledge applicable, or do they need to completely rethink the way that they structure the data that they're storing?
Actually, interestingly, they would need to just simplify the whole model, and actually, it would be a lot closer to how they would visualize it in their mind. So, taking the whole like Facebook post kind of example, you have a post pointing to a comment, which is a comment on a post. Then you have another comment on that comment. If you think in terms of graph, then you have a post and then a comment coming out of that, another comment coming out of that comment, and a like on that comment, and so on and so forth. So in terms of mind map, it's maybe like three or four bubbles connected to each other. But if you look at how you would represent this in a relational database, you'll have to have like different tables, and a comment on comment would point to the same table back, the foreign ID of that. But if it's a comment on a post, it will be a different kind of like a pointer back. It basically requires a lot more thinking to represent this in relational databases than it does in graph databases. So if anything, they would just need to sort of unlearn some of that complexity and go with the most natural mind map that they would think of and represent that in graph.
And my understanding is that at the sort of foundational layer of DGraph, you're using a key value store. And I'm wondering if that is reflected at the user interface and sort of query level when somebody's storing the data, if they are only able to store key value attributes, or if it supports more of a sort of rich document structure at the nodes or in the vertices.
Yeah, it's not reflected in the end user experience. So if they were to, we actually internally convert the data that we have, all these nodes and edges, etc. We represent them in a very interesting structure. For example, we would assign a unique integer to each node, and then if you need to store a list of your friends, we would actually store it in a single, what we call the posting list, with your friend IDs in a sorted integer fashion. And that's really useful because if you need to find common friends between you and somebody else, we get two posting lists and we can just do an integer intersection. In fact, intersection of two sorted integer lists, which is extremely efficient. So we kind of like stored these posting lists internally in the key value database that we wrote in house, and so we don't really expose the actual key value nature of this to the end user.
And I was reading through some of the blog posts and documentation for the Badger storage engine that you wrote, and I'm curious if that's being used within other projects or if it's currently only leveraged by DGraph.
Oh, it's definitely being used. In fact, Usenet Express, which is like running a news hosting site, I think they are running over like dozens of petabytes of data on Badger. We have IPFS, the Interplanetary File System, supporting Badger, using Badger, Zero Store, and there is actually a list of users on our website. And yeah, in fact, there's probably like a lot of Badger users. I gave a talk in GopherCon China, and I was explicitly asked to talk about Badger because there's a lot of interest of Badger in China.
And going back to dgraph, there are a number of different syntaxes that are used by some of the different database engines for queries. So there are things like Gremlin and Cypher and GSQL. So I'm wondering if you can discuss a bit about the query interface that you settled on for dgraph and your opinions on some of the other languages that have been adopted by some of those other systems.
So yeah, I mean, I have a bit of opinion about this. So Gremlin, I think when we were starting with DGraph, we had the same question. Hey, do we want to support Gremlin? Do we want to support Cypher? What should be our language of choice? And Gremlin is the most popular and the most widely used graph query language. However, if you look at the actual semantics of how it runs and how it actually the queries run, it's a bit too simplistic in that you are literally traversing the graph and telling what to return. You can't lose the relationship information from how you go from A to B. You don't really get a subgraph of result back. You just get like a list of result back, and it's actually slow to execute. So we kind of ruled out on that pretty early on. We looked at Cypher, and we had a similar conversation around that. Is again, you're returning a list of results as opposed to a subgraph. And you can always go from a subgraph to a list and normalize it, but you cannot go back from a list to a subgraph because you lose the relationship information. To give you an example, like let's say you're looking for movies by Tom Hanks, and movies where Tom Hanks acted and directed by Steven Spielberg, etc. So if you just return the list of movies, you lose which movies were acted in by Tom Hanks, and you actually want to maintain that information. So you want to support a query language which would maintain these relationships and return a subgraph back. And we came across GraphQL, and it looked like it was the right fit. I talked to some of the people back at Google as well, from MetaWeb, and it was close to MetaWeb's own query language. And we embarked upon using GraphQL as our language of choice. However, we also were aware that this is not a full-fledged query language for a database, and we ended up like modifying it to serve a database's needs and kind of simplifying it a bit more, so, adding filtering and I think a a few other things. Um, and removing some of the complexity that we thought. So we ended up with a modified version of GraphQL, and I think in fact one of the most asked features from DGraph is to also support the native GraphQL. Also, one of the most sort of interesting one for us is that when people play with our version of GraphQL and find it to be simpler to use than SQL. So that's how we ended up with it.
So, going a bit deeper, can you discuss the way that DGraph itself is architected and how that architecture has evolved over the course of time that you've been working on it?
So DGraph's architecture actually has been sort of continuously evolving, though it has, I think, largely I would say stabilized now. We started with a single server, architecture in version 0.1. I think then in version 0.2 or version 0.3, we went over to have multiple servers so that you could actually shard your data across servers. In 0.7, we introduced raft-based replication for these shards, so that it would be consistently replicated. And we were planning to like punt on transactions. We never thought we'd actually build transactions in DGraph for a while. And at some point, and Gustavo Nimier, one of a big personality in Go community, he created a very convincing issue in DGraph that he's been playing with MongoDB for a while, and it's really hard because MongoDB did not support transactions. Well, I think they now do, but at that time they did not. And he made us promise that we would support transactions, and that sort of like started a whole quest for us to see what it would take to support transactions in such a distributed system. And we then introduced transactions into Badger. We then actually tried out two different approaches to building transactions in DGraph, which required a lot of architectural changes. And then we settled upon the one that we currently have. And since the 1.0 release, we have been sort of, still sort of perfecting it and stabilizing it and so on and so forth. So yeah, it's a pretty unique system with a pretty unique architecture. Also because we have promised people that this is going to be fast, and that's what people really like about DGraph. So when we introduced transactions, we had to make sure that these transactions would perform. And so we made some choices where we chose not to go with the spanner style transactions, but more of sort of percolator slash HBase style, but then still modified it quite extensively.
And in terms of the schema definition, DGraph supports flexible schema or schema on write approach. So I'm wondering how you balance that flexibility with the additional complexity required at the application layer to support schema on read versus schema on write.
So yeah, I think flexible schema is absolutely important for developer iteration. I think we wanted to make sure that our users actually have that flexibility. So DGraph actually supports schema um, both on write and read. So what happens is, if you don't specify a schema up front, which is completely all right, DGraph would try to interpret your data and figure out whether it's a string or an int or a float or a date, etc. And then then it would kind of like set that schema for that predicate, and then all future data that is coming in would be checked against that. And in case you say, change the data type from int to float or int to string, then at the time of read, we would look at the type that is current and look at the type that was stored, and we will try to do a conversion if that's possible, and return back the result. So the end user does not have to do their own conversion. And obviously it comes with certain potentially CPU cost, but I think it saves a lot more for the end user.
So, in terms of reference to how somebody might talk about types, you could refer to the schema of dgraph as being dynamically but strongly typed, similar to Python, where once you assign the type of something, it will maintain that. But or you also have the option of assigning it dynamically. So I guess in that case, it's more akin to how you would interact with types in Go, where it will infer the type at assignment time and then enforce it for subsequent interactions. And then you also have the option of explicitly defining the types in the structure of the data so that any subsequent writes to that structure will enforce those data types and those sort of data shapes Is that accurate?
That's accurate. I think it's probably more close to Python in that sense, where you could have it were interpreted, but then you can then go and still change it after having used it, and it would be fine with that. As opposed to Go, where once you set it, then you cannot change that anymore. But in DGraph, you can definitely go back and change it, and even if you have indices upon that, it would recalculate. It would delete the old indices and recalculate the indices based upon the new type.
So, for somebody who's developing on top of DGraph, their workflow might look like they just sort of start putting data and objects into the database, and then as they iterate, it will adapt to their schema. And then once they have sort of cemented the architecture and structure of their application, they can then export that schema definition and then maybe propagate that to a production system so that the schema is defined ahead of time once you move that into the full operational base.
Yeah, I think that sounds absolutely the right thing to do. Because as you're iterating over your application, you learn more and more things. You figure out where you need more indices, where you what kind of data structure you want, and you just go in and modify that, and DGraph would take care of that for you.
Yeah, so that sounds like a good middle ground between MongoDB, where you just put data in and you hope that eventually you'll be able to read it out and that everything will be there, or something that's more rigorous, such as a PostgreSQL, where you're required to define the schema ahead of time.
Right. We do our best effort. Actually, we actually have a conversion logic where we can convert from what is stored to what is the current schema, and we'll do our best to do the conversion. And it's only if we really cannot find a path to conversion, then we would return with an error.
And in your documentation, and as we've discussed a little bit earlier, you contend that DGraph is a viable replacement for a relational storage system and can be used as the primary storage mechanism for somebody's application or data environment. So I'm curious what the potential switching costs in terms of technical and cognitive overhead exist for somebody who is looking to make that transition.
Yeah, that's actually hard to calculate. Honestly, depends upon how deep they are in it. Because database sits at the right at the bottom of the stack, and so everything is kind of built on top of it with that knowledge. Also depends upon if the team is largely engineers or there are sort of analysts or non-engineers in the team using the database. It's always a higher cost for non-engineers to learn a new database or a new technology. I think the right way to think about is DGraph the right choice for your next project, the one that you want to build. If you have many interconnected tables, then would they be represented a lot easily in a graph database? I've seen people with relational database with like so many different tables which are highly connected. So if you have, I would say if you have more than 10, that means that might be a good fit for graphs. And do you need to query across them? Do you need them to be to run joins, etc.? So if you have interconnected data sets, then by switching to DGraph, you could save a lot of backend code and developer time. So I think the right question should be moving forward. What's the best way to what's the best database to use, as opposed to ripping up what you already have.
And when I was reading through the documentation, I saw that there are people who are also using DGraph as their primary storage for search workloads as well.
That's right. And I think we are also there's companies, startups sort of built solely on DGraph and know the database. And we are also hearing that a bunch of Elasticsearch users who need join functionality, they are using DGraph for and switching from Elasticsearch.
And in terms of operationalizing DGraph and putting it into production, what are the limitations that people should be aware of in terms of the scalability or the overall usability of DGraph?
So I think in terms of scalability, there are no such limits. The design is so that it's pretty scalable, and we have had people running 3 node, 5 node, 10 node, 30 node cluster of DGraph. So as such, there is no limitation. I mean, Raft itself imposes some limitations on the size of the group. You typically want a replication of 3 times or maximum 5 times. They recommend not to go beyond that. But in terms of the sharding of data, you could actually have let's say, a 100 node cluster easily. In terms of usability, we still are sort of developing those tools which help you manage your cluster. Those are we actually have those APIs, but don't have any good sort of visual tools which can let you easily see and monitor what's happening in your cluster, what's going on, etc. So that still is a bit more challenge for from the ops side. I would say not too much because you still have logs and you still have the metrics and whatnot. But obviously, it is not as evolved in terms of tooling as relational databases.
And in terms of the cap theorem, where does it fall along the various axes?
So DGraph is CP. If we have a replica, if we have three replicated servers, and if two of them go down, then you won't be able to read or write. You have to have at least majority of them up. So yeah, we are CP.
And for somebody who is interested in building on top of DGraph and deploying it to their production environment, what is actually involved in getting a cluster deployed and operationalized, and what kind of overhead should they be planning for in terms of their server architecture?
Actually, it's not too hard to run a DGraph cluster because we don't rely upon it. Does not rely upon any other technology, and that was one of the design decisions that we had to make upfront. Particularly when we're doing transactions, we so I think it was HBase paper, and they were using Zookeeper for providing sort of transactions in a Raft based replication system, and we always stayed away from having to use a third party system to make it easier for us. So when you run dgraph, you just run one process, and if you need to scale it out, you just run multiple processes. So a lot of people use our Kubernetes configuration that we have on our site, or even Docker Compose. At least we do testing with Docker Compose, and a lot of people that we know are using Kubernetes to run the instances. Some of the big companies who actually have the ops teams, they just run the servers directly on the, let's say, Amazon, on the Amazon instances instead of running it in Docker. And yeah, I think DGraph basically just takes care of, like, doing membership handling and whatnot. So all you need is you need a one server to be up and running, and you can point any new server to that, and it just automatically connects and figures out what it should be serving. There's free data movement between servers if needed. It tries to make sure that each sort of group of clusters has approximately the same amount of data, so there's a good usage of RAM. Yeah, I think in terms of operations, it's not that hard.
And does it have any capacity for user management and authentication and security aspects?
Yeah, so that's where we still need to do more work. We are planning to build access control lists in DGraph. I think probably early next year. And currently, what we have is there is the TLS connections that you can have between the client and the server, but the communication within the servers is still unencrypted. And the idea is that they'll be behind a cloud that you can then tightly secure. But obviously, more work needs to be done in terms of, for example, encryption at rest, and communication, encrypted communication between servers, access control lists to make sure that you don't have users who are not supposed to do things, etc.
And in the process of building DGraph and growing the community around it, what have you found to be some of the most interesting or challenging aspects of that process?
Building a new database is just very challenging work to begin with. Despite my time at Google, and I was working on pretty complicated problems there, I felt like we were up against like a mountain load of work, and our own understanding of things to be able to build this practically a beast. You need to get to a with a database. You need to get to a certain level of functionality before the database is of use to others. So there's just time where you're just building and building without any majorly visible or changes or any sort of like positive outcomes, which can kind of get to you. So it's not really for the faint-hearted. And the community growth actually has been pretty steady, slow and steady kind of thing. We started off with announcing DGraph. We started putting content out there our blog posts and stuff, we build like demos. For example, we built a demo where we put the entire Stack Overflow on DGraph and put that in open source. And when people came to us, we just helped everybody that we could get to. People who had issues with DGraph or had feedback, we tried to respond to that. In fact, we told people that the best way to contribute to DGraph was to file an issue. It was not to contribute code, but to actually just file an issue. Tell us what doesn't work, what bugs or issues you faced, what you want to do, but you currently cannot do because of DGraph's limitations. And we responded quickly to their questions, and which actually helped solidify the team's sincerity to our community. And they just kept growing to a point where now we actually have to have dedicated people handling them. We just don't have enough bandwidth to handle the community.
And I understand that early on in the process of building DGraph, you had it fairly restrictively licensed with, I believe it was AGPL, and you realized that that was actually an inhibiting factor to people being able to use it within their companies, and so you ended up relicensing it. So I don't know if you want to talk a bit about that overall experience.
For sure. So actually, we started with the Apache license, and at some point we looked at MongoDB, and we thought, hey, we should really like we want to build a company like them, and they are sort of guide for every other, I would say, database startup out there. And we went with AGPL, but then we started realizing, I think Google's open source team was pretty vehemently against AGPL, and they banned AGPL from Google, which probably caused other big companies to also have equal bans within them. And so, without naming any names, and when they started talking to some of these companies, I mean, they reached out to us. They just told us that they can't even. Some of the developers in those companies, they couldn't even. Like bring it in to their code base because of the license. And so we decided to figure out what's the best way for us to to still have Apache license, but also be able to build a business around this company. And that's when we ended up switching over to Apache, which is modified with a commons clause restriction. And the good thing about this restriction is that if you're just wanting to use and build a commercial product on top of DGraph, you're not affected. It only basically restricts you from selling DGraph, the database itself. And most of our users plan to use DGraph to sell something, but not sell DGraph itself. And so, this is a very good license. And we actually only heard positive things about it since our change. And actually, since then, we actually have onboarded a bunch of really big companies who are now using DGraph in production.
And are there any particularly interesting or unexpected uses of DGraph that you've become aware of?
I think there was one interesting one where this company had something like 51 different data silos, like data coming in from different streams, and in so they actually had 51 different database instances which could not talk to each other, and they wanted to be able to query across them. And so they are using dgraph to stream in sort of like data from many of these silos into a single dgraph database cluster, and now building an app on top of this information which they can now query across. That was like just the number, like 50 database instances to me was like pretty crazy. And so I found it to be pretty interesting.
And when is DGraph the wrong choice when somebody is considering building a new platform?
These days I think a lot of people want to have a time series database, and time series database by definition is very flat data set which just has a lot of data points but not a lot of connections. And so for those use cases, I know people are still using dgraph, but I would say that's not what it is designed for. It does support date time, it does support indexing of that, but it's not really designed to be a time series database.
And as you continue work on DGraph, both the project and the business, what do you have planned for the future?
So I think our current focus is still on the actual DGraph project. We want to make sure that it is working for its users, that our users are happy, and we actually, as I said, we have been stabilizing the database. We actually have Jefferson test report coming up by the end of this month on DGraph, which actually helped us fix a lot of issues. And we have a roadmap for this year with feature requests that people have been asking us for a while now, that we need to deliver upon. And so I think that's where the focus is still on making sure that DGraph, people who choose DGraph, it's a success for them.
And are there any other aspects of DGraph or graph databases in general that we didn't discuss yet, which you think we should cover before we close out the show?
There was a question, I think, around some of the I think I would say sentiment around graph databases that keeps on coming up, where people feel that that graph databases don't work or they don't scale, etc. And actually, I always like have a very sort of philosophical argument to that. And so I thought I'll probably share that with you. We have just take language as example, right? So we have many experiments in different computer languages. We have C++, which are really old, Java, but then lately we have seen like Python and Ruby and now Go. There's a lot of experimentation with languages. New languages are designed to help with developer iteration, and that comes even at the cost of machine utilization and user experience. But when it comes to databases, many developers tend to take a single-minded view that SQL is king. However, SQL databases can slow down developer iteration when compared to their modern alternatives, easily doubling the code base size compared to graph databases. And I think those development costs need to be considered and rationalized. And that's the biggest gap I think there is in terms of understanding. It's not in terms of a tool or a technology, but a culture of sort of worshipping all the databases over new, almost I think at the cost of engineering, that sort of slightly sort of irks me or upsets me. I think that needs to change.
Well, for anybody who wants to follow the work that you're up to and get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, you answered this a little bit just now, but if you could share your perspective on the biggest gap in the tooling or technology that's available for data management today.
I think we have a lot of tools already built, and they are probably like new tools almost like being built on a daily basis. I think the biggest one would have to be coming in terms of what developers are willing to try. Right. I see, as I said, the companies are willing to try new languages, and I think more companies should be willing to try new databases to achieve maximum developer productivity.
All right. Well, thank you very much for taking the time to talk about your work on DGraph and for the wonderful job you've done on it so far. So, thank you for that. And I hope you enjoy the rest of your evening.
Thank you. Thanks for having me.